Now let us discuss about operator precedence parser in compiler design. Operator precedence parser is a bottom-up parser. Operator precedence parser mainly uses operator grammar and constructs operator precedence relation table. So based on the operation precedence relation table, we have to parse the input string. From the parsing of the input string, we can generate parse tree. So here our major aim is in order to generate the parse tree. First, let's see what is operator grammar. It is mainly useful in order to define mathematical operations with some restrictions. So by using operator grammar, mainly we can perform some mathematical operations like plus, minus, star, division, modulo, likewise, with some restrictions. The first restriction is two variables cannot be adjacent on the right hand side of the production. Let me have a production like this. S produces AB. It is not allowed here. Why? Because two variables cannot be used in the right hand side of the production. Let me have a production like this, ABD. So this is also not valid. Two adjacent variables cannot be accepted in right side of the production. So this is one adjacent pair and this is another adjacent pair. So this is not allowed. And the second rule is no epsilon on the right hand side of the production. Suppose if we have epsilon in the right hand side, then also we can say that it is not an operator grammar. Okay. So let's see some examples. First example, E produces E plus E or E star E or ID. If we observe this production, E plus E, so here there is no problem. So two adjacent variables are not there. So here also there is no problem. And ID, we don't have any epsilon. So we can say that this is operator grammar. This is operator grammar. There is no problem here. Let us take this example. E produces EAE or ID. A produces plus or star. Second production is operator grammar only. But coming to the first one, this is not operator grammar. Why? Because here we have this is two adjacent variables and AE. This is another adjacent variables. Okay. So it is not allowed. But we can convert this non-operator grammar into operator grammar. So let us convert this non-operator grammar into the operator grammar. Here what is A? Plus and star. So now in place of A, if we substitute plus and star, then it will become operator grammar. So let us see the production. E produces E in place of A, first to produce the first production, that is plus, next E, or we have one more A production, that is star. So let us substitute that one. E in place of A, substitute star, next E, next one is ID. Next A produces plus star. A produces plus star. So likewise we can convert non-operator grammar into operator grammar. In the examination you may get non-operator grammar also. Then you need to convert that non-operator grammar into the operator grammar by substitution. If we have epsilon, we know how to remove the epsilon productions. So we have to remove that epsilon production also. Okay. Let us see this example. S produces SAS or A. So this is also non-operator grammar. This is also not a operator grammar. So how we can convert this non-operator grammar into operator grammar? So S produces, yes, what is A here? BSB. So in place of S, substitute BSB. BSB. Next we have S. So let us write that S here. Or what is the another production for A? B. So in place of, so yes, what is A? BSB. Next yes. So for A we have another production, that is B. So S, B, S, A. Next A produces BSB or B. So we know that this grammar is what? Ambiguous grammar. E produces E plus E or E star E or ID. This grammar is ambiguous grammar. But operator precedence parser except with some of the ambiguous grammar also. Some of the ambiguous grammars also. Operator precedence parser handles this ambiguous grammar. There is no problem. Okay. Let us see this example. So in this class we are going to discuss about this example. Here we have a grammar like this. E produces E plus E or E star E or ID. So now our target is we have to parse the input string ID plus ID star ID. Okay. So this string is given in the examination. Suppose if the string is not given, then from the starting symbol we can easily generate another string. E produces E plus E. What is E? ID. So we can directly write it as ID plus ID. Or what is this E? E star E. So the production will become ID plus ID star ID. Or we can have another string ID star ID plus ID. It is your choice. In the examination, if the string is given, not given, then from the grammar easily we can generate an input string. So totally we have to follow 4 steps here. Step 1 is check whether the grammar is operator grammar or not. So there is no problem. This grammar is operator grammar. Why? Because it is satisfying 2 properties. What is the first property? 2 adjacent variables cannot be on the right hand side of the production. And what is the second one? There is no epsilon. So it is satisfying both the properties. So it is operator grammar only. So second step, construct operator precedence relation table. So we have to construct operator precedence relation table. Step 3 is parse the input string. Step 4 is generate the parse tree. So now let us solve the problem. So what is the grammar here? E produces E plus E or E star E or ID. So for this grammar, we have to construct the parse tree. So first we need to check whether the grammar is operator grammar or not. If it is not operator grammar, then we need to convert that non-operator grammar into the operator grammar. Okay. But in this example, operator grammar is given, so there is no problem. So what is the next step here? We have to construct operator precedence relation table. Okay. So let us see here. It is right here. Operator precedence relation table. So we need to convert operator precedence relation table. So here we have to construct operator precedence relation table based on the terminal symbols. Okay. So the grammar is E produces E plus E or E star E or ID. Here what are the terminal symbols? Plus, next star, next ID, and we have to use dollar also. Dollar also. Why? Because input string ends with dollar. So plus row also plus star ID dollar. We have to fill this table now. We have to fill this table now. So based on this table, we have to parse the given input string. So for this, we need to follow some rules. The first rule is, if it is ID, that means if it is a variable, it may be ID or A or B, any variable, then we have to give the higher priority. Higher priority. So ID is greater than any other symbol. Okay. A is greater than any other symbol. Okay. Next one is for dollar. For dollar, we have to give lower priority, lower precedence. Okay. So dollar is lesser than any other operator, any other symbol. So next one is if we have plus and plus, plus and plus. So this plus is stack topmost symbol. This plus is input symbol plus. In the input string we have plus. The first plus is stacks plus. Stacks topmost symbol is plus. We know that plus is left precedence, left associative. Why? Because if we have an expression like this, so 1 plus 2 star 1 plus 2 plus 3. Okay. So here this expression contains 2 pluses. So now based on the associativity, we have to evaluate the expression. The associativity for the plus is left to right. So associativity is left. So first this expression will be evaluated. Next this 3 will be added. So that's why here we have to give more precedence to the left to plus. Left to plus. So plus, for the plus, this first to plus. That means this left to plus has higher priority. Okay. Why? Because plus means we have to follow left associativity. Okay. So likewise, if we have plus and star, then we have to give more priority to the star. Star has higher priority. Okay. Likewise, if we have star and star, we know that star is also left associative. Star is also left associative. If the expression contains two stars, then the expression will be evaluated from left to right. So we have to give more priority to the left star. Okay. Now let us fill the table. Plus plus. So plus plus means give more priority to the left to plus. So left. So left to plus has higher priority. Next to plus star means star has higher priority. So we have to use what? Less than symbol. So plus has less priority than star. So star is having higher priority. Next to plus and ID has higher priority than any other operator. So we have to use less than. So less than specifies that plus has less priority than ID. Next, plus dollar. Plus dollar. Dollar has least priority than any other operator. So which symbol we have to use? Which symbol we have to use? Greater than. So plus is greater than dollar. First one, plus is greater than plus is less than star, plus is less than ID. Next, star. Star plus means star has higher priority. So is greater than. Next, star star means left associative. Next, star ID means ID has higher priority. Star dollar means dollar has least priority. So we have to use dollar greater than. Next, ID plus means ID has more priority than any other operator. So use ID symbol. Okay. Use, but ID means we can't compare two IDs. This situation never arises. ID. This situation never arises. So we have to use hyphen. Not possible to compare. Next, dollar plus means dollar has least priority. Dollar star, dollar has least priority. Dollar ID, dollar has least priority. Next, dollar means we can say that input string is accepted by the operator precedence parser. Okay. So based on these priorities, we have to construct the operator precedence relation table. Okay. So plus means plus, already we have seen this one. Star means star has highest priority than plus. Next, star star means for left star we have to give the more priority. Star ID means ID has higher priority. Star dollar means star has higher priority. ID means ID has higher priority. ID can't possible to compare. So use hyphen. ID dollar means ID. Next, dollar means less than, accept. Okay. Now let us take the input string ID plus ID star ID. Now let us parse the input string. Let us parse the input string. In order to parse the input string, we require 4 columns. The first column is stack. What is the content of the stack? That we need to write. Second column is relation. Relation means which operator we are using. Which operator? This table. We may have either less than or greater than or minus or accept. Okay. Next one is input string. So what is the input string that we need to parse? Input string. So here which string we are parsing? ID plus ID into ID. But here every string ends with dollar symbol. So we have to write dollar at the end of the input string. Next one is operation. So which operation we have to perform? Okay. Initially the stack topmost symbol is dollar. So what is the stack topmost symbol? Dollar. So we have to compare dollar with what is the in input string, what is the first symbol? ID. So dollar ID. So which one is having higher priority? ID is having higher priority. If the input symbol has higher priority than stack topmost symbol, then simply we have to perform the push operation. Push means we have to perform shift operation. So shift, we have to shift the input symbol. What is the input symbol? ID. Suppose if stack topmost symbol has higher priority than the input symbol, then we have to perform the pop operation. Pop means we need to perform the reduce operation. It is just like infix to postfix conversion algorithm that we saw in data structures. Okay. So what we have to do now? Here dollar ID, stack topmost symbol is dollar, whereas input symbol is ID. So dollar ID means compare dollar with ID. So dollar with ID. So dollar with ID means this column less than. So that means ID has higher priority. So we need to shift ID now. So now the content of the stack will become dollar ID. So we are pushing this ID into the stack. Shifting means push. Okay. Now this ID is over. So what is the remaining input string? Plus ID star, ID dollar. plus id star id dollar. So now what is the stack topmost symbol id? Next, what is the input symbol plus? So id plus id plus id plus id has higher priority. id has higher priority. If the stack topmost symbol has higher priority, then what we have to do? We have to perform the pop operation. So pop means we need to perform the reduce operation. So reduce. Here what is the stack topmost symbol? id. What is id? E. So we have to reduce id to e. So that means in place of id, we need to replace id with e. So replace this id with e. Next, here we have to use that plus only. There is no change in the plus. Here what we are doing? We are performing the reducing operation. So let us write the input string as it is. Plus id star id dollar. Now what is the tag? What is the stack topmost symbol e? But here we can compare only terminal with terminal. But what about e? E is a variable. It is a non-terminal. So we can't compare e here. So what is the next terminal symbol? Dollar. So now we need to compare dollar with plus. So non-terminal can't be compared here. Okay. So dollar with plus. So which operator has higher priority? Less than. So that means plus has higher priority. Input symbol has higher priority. If input symbol has higher priority, then we have to perform shift operation. What is the input symbol? Plus. So we need to shift plus. We need to shift plus now. So now the content of the stack will become what? So dollar. The content of the stack will become dollar e. So now we need to shift that plus. Now this plus is over. This plus is pushed onto the stack. So what is the remaining input string? id star id dollar. Okay. Now what is stack topmost symbol plus? What is the input symbol? id plus id. Plus id means what is the relation? Less than. So that means input symbol has higher priority. If the input symbol has higher priority, then we can perform the push operation. So shift id. So now we need to shift this id onto the stack. So now the content of the stack will become dollar e plus id. So this id is pushed onto the stack. So what is the remaining input string? Star id dollar. So now what is stack topmost symbol? id. What is the input symbol? Star. id star. So what is the operator? Greater than. That means stack topmost operator has higher priority. Then we need to perform pop operation. Pop means we need to perform the reduce operation. Here what is the symbol? id. So reduce id to e. So now, so dollar e plus, in place of this id we have to write e. Next, there is no change on star. Why? Because previously here we have performed reduce operation. So dollar id dollar. So now what is stack topmost symbol? E. But E is a non-terminal. Non-terminal can't be compared. Here we have to compare terminal with terminal. So beside this we have plus. So now we have to compare plus and star. Plus and star means what is the relation? Less than. So that means star has higher priority. So we can push star. So shift star. So now the content of the stack will become E plus E. So we have to push this star. So star is pushed onto the stack. So now the remaining input string is id dollar. So now we need to compare star with id. What is the relation? Less than. So that means input symbol has higher priority. So we can perform the push operation. So shift id. So dollar e plus e star. So push id. So now id is pushed down to the stack. So now the input string is dollar. Input string is id is processed now. So the remaining input string is dollar. So now stack's topmost symbol is id, whereas input symbol is dollar. id dollar means what is the relation? Greater than. So that means stack's topmost symbol has higher priority. So we need to perform reduce operation. So here what is the input symbol? id. So what is the stack's topmost symbol? id. So reduce E produces ID. So now this ID is reduced to E. So dollar E plus E star E. So now what is the content of the input string? Dollar. Dollar. E dollar. E is a non-terminal. So we can't make any comparison. What is the next symbol? Star. So star with dollar. Star with dollar. So star with dollar means greater than. Greater than. So star has higher priority. Star has higher priority than dollar. So greater than means which operation we have to perform? We have to perform the pop operation. Why? Because stack topmost symbol has higher priority. But here what is the expression? In between E and E we have star. So we have to reduce E star E to what is E star E? E. So reduce E star E to E. So now this E star E will be reduced to E. So dollar E plus E. So this E star E is reduced to E. Next dollar. Okay. Next E. E. This is a non-terminal. So we can't make any comparison. Next plus. Plus dollar. Plus dollar. So plus dollar means greater than. Greater than. So stack's topmost symbol has higher priority. So what we have to do? We have to perform popping. Popping means reducing. So reduce here plus. So we have to reduce E plus E to. We have to reduce E plus E to E. Reduce E plus E to E. E plus E to E. So now this E plus E is reduced to E. E. Next dollar. Dollar. Next E dollar. We can't make any comparison. E means non-terminal. Next we have dollar. So dollar means accept. So we can say that our input string is accepted by the operator precedence parser. Now we need to generate parse table. Parse table. It is a bottom-up parser. Bottom-up parser means we have to start from the bottom and proceeds till we get the top. So here what is the symbol? It at the bottom. At the bottom we have E. So E. Next E produces E plus E. E plus E. E plus E. Next what is this E? Second E. E star E. Second E means E star E. E star E. E star E. Next the last E is producing ID. The last E is producing ID. Next this E is producing ID. This E is producing ID. Next this E is producing ID. So this is our input string ID plus ID star ID. So this is our parse tree. So this is about operator precedence parser. In the next class we will discuss one more example on the operator precedence parser.